Okay, so this is the fourth question of IT JEE Advance 25. Okay, paper 2. And what we have to find, we have two stars. A stars of mass m2 is revolving around a circular orbit, and the mass of the central body is m1, and m1 is very large. Okay, the heavier a star slowly acquires mass from the lighter star at a constant rate gamma kg per second. Okay, so basically we have one star here, and at a distance r we have a smaller star m2. M1 is very large. Okay, so M1 is given what, very large. Okay, and it is losing mass, it is gaining mass. Okay, and because of this mass transfer, what will happen, this r will change. We have to basically find 1 by r dr by dt. Okay, and in the process there is no loss of mass. That means m2 is losing the mass, m1 is gaining the mass, but total mass loss is 0. Okay, so mass is conserved here, and one more thing will be conserved here. And what is that thing? Angular momentum. Okay, and angular momentum will remain conserved, and in the problem we have to use that. Okay, actually when I did this problem, I got it wrong. Then I did it again and I got it right. But there is a problem. I'm not getting minus sign here. Okay, so I will explain my opinion. Okay, not opinion. What I think. Okay, so first it will have some orbital velocity v. Okay, so you can also see that m1 plus m2 is the total mass, and this total mass m is also very large compared to m2. Okay, first you have to see this. Okay, so orbital velocity formula we already know, under root g m1 by r. Why m1, why not m2? We have seen in gravitation chapter that orbital velocity depends on the central body mass only. Okay, mass of the central body only. Okay, not on this body. Okay, provided this mass is very small. Okay, this mass is very small compared to m1. Okay, so this is orbital velocity, and angular momentum. Angular momentum here will be angular momentum here will be m2 vr. M2 vr. We write mvr, but I will write m2 vr. Okay, because this mass is moving. We have to find the angular momentum of this body compared to this body. Okay. Now, let us see. And this angular momentum is constant. Okay. So m2 is m2, v is g m minus m2. I have written m minus m2. Why I have written m minus m2? I have written m minus m2 because I don't want so many variables. Okay, so m1 is removed. This capital M is not a variable. This is constant. Okay, and if you simplify it, you will get m2. Okay, if you simplify it, I will square it also. Okay, if you do it, you will get L square m2 g. M2 is a squared. Okay, this is a squared, this is a squared, other things will not be a squared. Okay, g m minus m2 into r. Okay, and this part is constant. Okay, Because we have to find this thing, I would like to write 1 by r. So 1 by r will be 1 by r will be g m2 square minus m2 the whole cube divided by l square. This is 1 by r square. 1 by r. 1 by r, this thing by l square. I multiplied this m square here because obviously we have to do the differentiation, okay? So what I will do, 1 by minus 1 by r into r dr by dt. Okay, we know this formula, okay? Differentiation of 1 by r is what? Minus 1 by r square. Okay, I'm doing the differentiation with respect to time. And let us differentiate here. G is a constant, L square is a constant, M is a constant, and 2m2. I have to write dm by dt also. I have to write dm2 by dt also. So, but I will write it outside. And if you differentiate it, you will get 3m2 square dm by dt, okay? 3m2 square dm by dt. So what are the things we have? Minus is minus. Minus I will write. Instead of 1 by r, I will write this whole thing. G capital M. Sorry. I will take m2 square common. Okay, m2 square common. So m minus m2 and l square is there. Okay. Okay. This thing is only for 1 by r. Okay. This whole thing is only for 1 by r. And 1 by r dr by dt is still there. So let us see what we did. This minus 1, this is minus 1. This whole part is 1 by r, and then this part is written here, okay? And this side, it is g by l square, g by l square. This side we have g by l square into, okay, I will write, I can take 1 m2 common, but no problem. Okay, let me take 1 m2 common, okay? gm2, and this will be m2m minus 3m2. I have written everything, but one thing I have not written, and what is that one thing? That one thing is dm2 by dt. What is dm2 by dt? See, heavier mass is gaining the mass and lighter mass is losing the mass. So dm2 by dt will be actually minus gamma, okay? Right? And dm1 by dt will be plus gamma. So I will write a minus gamma here. So what happened here? This thing becomes plus. We don't have to worry about it. G by L square will get cancelled. Okay. One of the M2 is also getting cancelled. Okay. One M2 is still there. Okay. So 1 by R dr by dt. This thing we have to find. And this will be what? This side we have 2m minus 3m2 into gamma m2 into gamma divided by this m2, okay, divided by this m2 and divided by m minus m2, m minus m2. Now this thing looks complex, but this capital M is very large compared to M2. So basically I will write gamma by M2, gamma by M2, I will write gamma by M2. This part I have written, okay. This part I have written. And what about this under parenthesis? See, this by this will become 2 because M2 is very small compared to M1, okay. So it will become, a limiting case will be 2m by m, 2 by 1, okay. So I will write 2 here. So what I get? I get positive, okay. So I get this thing, okay. Actually I get this answer, but there was no positive answer, but I am sure that this will be positive. Let us see how. First of all, the lighter mass is losing the mass, so its velocity will increase. To keep the momentum same, velocity will increase and radial distance will also increase. So basically dr by dt will be positive. Now some people will say uh, kinetic energy is also increasing. How the kinetic energy is increasing? Actually the potential energy is decreasing because mass lost from M2 is going to M1. In this process kinetic energy is lost. So I am sure that answer will be with a plus sign, but let us see what IIT says. Okay, it looks like some mistake, okay.